Okay, hello, assalamualaikum. This is Adi again. Okay, let's go for this update. So basically, I've changed the proposal a little bit because of what I've been done inside the proposal. So this is basically instead of just a review, it's an evaluation. Okay, research assessment, and I add on the coal-fired power plant because there's a subject of the study here. Okay, so basically this is the Gantt chart. The earlier one I didn't update much because now the research is almost like 80% completed. Write up also is similarly 70% completed. Okay, we go on this the introduction, the dissertation background, which is the insurance and risk assessment. Been talking about again about the reinsurance, the meaning of it, and the risk assessment has been done by the insurance, which cooperating the COPE, construction, company operation protection and equipment analysis. Okay, and then we go for 1.2, the current trend issue problem, which last time we mentioned of this. The circle one, the red color, which is no standard or technique for risk assessment and estimation, lack of choosing the base scenario. Okay, so basically what we have done here, we come up with a hypothesis that there's no standard, there's no lacking here and there. Okay, so basically this is a survey we run through all the not all reinsurance company in Singapore and Malaysia. Okay, and then yes, it's confirmed that it's not easy to obtain because some of the information are deemed as a company proprietary, so they don't want to share the informations. And then most of them are agree that this is like the standard of this is lacking and here and there. So now it come the questions like, is it possible to suggest for the guideline here? Although it's we will gone through we will go through inside this presentation and see whether this is actually a valid questions. But I still believe that providing a simple guideline will do help because not all the companies are actually big to have their own technical knowledge. Some of them are actually small, so this could be a very helpful for them. Okay, and then we also come up with the alternative in calculating the loss, which is the PML here lah, for the coal-fired power plant. Okay, so again, this is the coal-fired power plant. Is actually like 38% still being used in the world, mostly in Asia. We're gonna talk about the basic and then the terms, the theory of this coal-fired power plant, and how risk assessment could be done within this coal-fired power plant. Okay, so the aim objective here, as you can read through, we're going to provide you a concept. Okay, so read it. By the end of reading this, you can understand the insurance, what is insurance, the risk assessment, and its comparison to RBI. Why do I compare it with RBI? Is because RBI will give you a good indication of a risk assessment that need to be done. Okay, uh, and then understanding the concept of loss calculation, fire, coal-fired power plant. We're gonna look of some empirical losses, risk assessment, and how an actual risk assessment being done on a single plant, which is a sample case study for us, and we're gonna calculate the alternative of a loss. Okay, so the limitation here, the few things, mainly the study that I've actually referring was done by some other person, but it was not cited by many. It's I think since 2008. Okay, and then it's not interesting topic in the academia. And then last estimation for chemical plant, normally you have a tool, but this one we have no tools. Okay, so we need to come up with ideas on how to calculate loss. And then but most importantly is because of the world nowadays is moving into less coal, so the outcome of whatever my research might not be useful in the long run, because if let's say coal is not being used anymore, so there's no coal fired power plant. Okay, and also because of a timing given, I think if even if more timing is given, if you really put more effort to it, you can achieve more. Okay, so we go into the literature review, the concept of insurance capacity retention, what I explained before. This is I put it under the literature review. Okay, and then some risk assessment and loss estimation theory, I've been using this to explain. And then these are some part of the hazard identification and risk assessment, where you come up with this table of risk. Okay, and then again, then after that we go for this the methodology of insurance type of risk assessment. Okay, basically you describe of the plan, where do you get the plan data and everything. evaluation of the hazard. Okay, uh, normally this can be done when you do the site visit. Okay, when the site visit, you conduct the what hazard identification analysis there, so it's easier. Plus the person who conducted it, if they have a prior knowledge about it, loss history, and then for the same occupancy, it help them. And then they go for the loss exposure estimates, which here I show you is the one that being used in the insurance, but it's too long. But we are trying to focus now on our work now. It's just the physical damage, not the after damage. Okay, recommendation risk rating as I presented on the before. And then 2.4 again, this is where we dig a little bit about the RBI concept from the API and ASME, and we do some comparison between these two. And if you look at the down there, they are still calculating some loss, okay, based on the monetary loss basis. But again, may I remind you that this API and ASME actually calculating for equipment rather than the loss in the building or structure or maybe the whole thing. Okay, and then we move forward. Okay, this is not supposed to be 2.4, it's 2.5. Is the concept of the PML, MFL theory and everything. Okay, this was presented before. Okay, PML probable maximum loss, MFL maximum foreseeable. Basically, MFL is higher than the PML. They consider a passive protection, where PML consider active and passive. Okay, and then I will explain later. This is how we conduct the PML. Okay, there's no so many terminology in this, but we're going to focus on this two only, PML and MFL. Okay, so these are the some common scenarios that you're gonna see on the coal-fired power plant. Okay, but this the one that I'm putting here is actually a combined cycle. So basically, you can see that they put loss based on just gas turbine, steam turbine, but for coal, it's include the boiler. Okay, they don't calculate most of the other thing like transformers. Some of them may calculate because for them the basis of this is trying to get the highest value, highest amount of equipment or building where they calculate the loss. But eventually, as compared to, we see some loss record previously, right? So if you look at this one, even compared to the fire, machinery breakdown causes more losses. Okay, and then within the machinery breakdown also, you can see here the turbine generator transformer is actually generating more loss than the boiler. Okay, and even for this, even I try to subtract all the losses within the coal fire, and even if you see here, there's only one boiler loss in 2008 causing 1.6 million. The rest doesn't involve boiler. So now the question is, should we use boiler as our loss estimation calculation? Yeah, we need to think again. So we go into the methodology. As I mentioned before, most part of this will be a desktop review, some other interviews, and also I will include the desktop research, include the calculation that I'm going to present at the end of this work. Okay, we did this market survey out of 57 companies that being identified in Malaysia and Singapore for reinsurance business. 36 came back, that's around 63%. So what's the outcome of this? Okay, so out of 36, 34 if saying that they are involved in this writing coal-fired power plant, okay lah, so we take it 34. Out of these, 5 companies not using loss estimation because they calculate the capacity based on the total sum insured being involved. Okay, 34 involved in power underwriting is saying that they need a risk inspection report, and then half of it, which is 17, okay, they are saying that they are using the report, the loss estimation provided in the report, given the reason like this, reputable engineer, because they themselves don't have a capability. And for those who are not using the loss estimation, the report also giving their reason of this. They have their own way of calculating the loss. Okay, and surprisingly, after that, when I asked whether they have any software to calculate loss, yeah, 70 of them saying that they have a loss estimation tools lah. Okay, so and then I said whether, and then the question further asked like whether can they actually calculate the loss in power plant, especially coal fired. Okay, only 10 said yes, the rest said no, and out of the 10, only one saying that this is available in the open market, which I'm not sure what. Okay, the rest saying that no, because I think they just created themselves by using Excel. So that's why I'm also trying to calculate, and that's why I'm thinking that maybe because of that it's not supposed to be information need to be shared public, because this is like achievement or whatever they can calculate by themselves, right? Okay, so now we go further, understanding operation association risk protocol fire power plant using the HIRA. So basically using this, you do the likelihood, severity and risk class. These are actually taken from a 3 research study before mentioned down there. So basically we can see the risk class, moderate, low, high. Okay, and then I will focus more on this high, okay, and extreme, because these are actually where our loss estimation need to be calculated from. Although if you see here, the severity is actually high but the likelihood is small. Okay, but these are what the insurance are doing it. Okay, so it's not much different from this IBI approach. Okay, when we go this into the real coal-fired power plant in Malaysia, this is trying to validate what is our assessment. Okay, and then okay, I must say that okay, if you look at this, right, you can see the COPE, which is the main thing here, and you see within each category you see layout, plant hardware, fire protection, and within that itself we have so many denominator. So this denominator is total up somewhere around 62. Where I got it is actually I try to compare at least 10 survey assessment report done by in the insurance industry, and single out all the things that they are looking at. So basically I add up everything is somewhere around 62, and out of this I have 4 companies which done the assessment in different year of the same plant, which is this plant lah, thermal power plant. Okay, each one of them are giving a very different rating. You can see average, below average. One of them they didn't give anything, and then you see all the YY here they tick because they mentioned something about it in the report. Okay, but you see there are so many empty things also. Okay, this is also confirmed that there's no standard because people can just mention what they want, but a great effort was actually mentioned on this improvement, risk improvement. Okay, like these two company here, the second and the fourth one, they mentioned in the great detail, like half of the report are actually mentioning about how can they do better. Okay, that's why although here they only represent 41% of the item here being involved for the inspection, but they go into detail. Each one of them have very different what impact. Okay, and this is the calculation of a loss that they come out with. So if you look at here, PML of fire explosion, this is based on the explosion and fire. Another is machinery breakdown. They go for the boiler explosion. This one severe damage to the steam turbine. With these two, they come up with the calculation of 253, 217. These two are actually by the same company, and these two below here, the yellow color, are by the same company as well. But again, if you see the scenario mentioned here, they are all different. Even the numbers, okay, the numbers are pretty much different, except for the top risk that they calculated, failure of unified boiler. Okay, this is around 259, whereas this is boiler explosion come at 253. Although they are all in the range of 200, but they are very much different. Okay, there's no standard, there's nothing mentioned here. Okay, so basically what are we trying to do? We're trying to actually provide an alternative of a loss estimation calculation using the TNT equivalent. Okay, so basically these are the formula, Blasiman, and then we are check using the mass TNT here to find the scale distance. So from the scale distance you can find the scale overpressure. Compare back to this graph which provided by this Kenny and Graham, the explosive shock in air. So you could roughly get an idea of what damage you could have, minor damage to house or what, because this is based on this, right, 0.55 overpressure here. But again, this is not what we are looking for, because what we need is actually a comparison of how much an explosive could occur and affect. Okay, so basically we're going to use this equivalent amount of TNT using this formula here, and take note of this. Okay, this is the delta H here, the energy of explosion of the flammable gas, which info are normally found in the internet. Okay, you can have hydrogen, methane and everything. Even for this NIST, they come with a coal. Either you want to calculate it here, or we can do for another alternative, actually trying to calculate the heat of reaction, which is the change of enthalpy. We're talking here about the boiler of the product and the reactor. Okay, whatever the terminology is, okay, heat of combustion, detonation, heat of explosion, these are all actually the same thing because they are trying to imply calculation of the enthalpy. So we're going to use this to input on our equation. So once we get the TNT equivalent, what do? We can either use the overpressure. Okay, I haven't done until this. Okay, that's the remaining of my 20% of my dissertation. So once we have to do this, and then we go to the overpressure, find the scale distance, or even put in the Aloha, which is a free open software, and you can determine the pressure of area from the center of the explosion. Okay, and then the power, the what destruction of the building that they can have based on the what distance. So from this we can apply to a real mag. Even the Aloha can do that. Okay, so what they do, this is an actual plant of the power plant that I'm using it for my study. So basically, let's say there's a one two three boiler house here. So let's say like the calculation just now, they are using boiler number 5, right? So let's say we are taking this boiler number 5 here for an explosion. Okay, this is just mere example here. Okay, so let's say the first radius, second and third radius will come out around this 80 45. How we're going to translate it into monetary loss is actually, now we have this radius inside here. What we're going to do is we calculate the area inside this. Okay, how do we calculate area inside? Then we can just use a graph paper where we can calculate like, you know, like those darjah dua, all the peta, all the calculation within this. So we have the build up area, let's say it's 40% out of this 100%. So this 40% times 80% of damage ratio times the amount, moderate amount, so we can get the loss, and then we add one by one to get the whole amount of loss. Okay, so important thing here, what we need is the actual amount of each building or the equipment. Okay, let's say we categorize this as a one building, two building, three building, so we need that. Okay, and then second, we need a distance to be able for us to calculate. Okay, so once we got the calculation, we can compare back. Okay, whether how is it different from the one calculated by the consultant. Okay, but at least we're giving them some signs and show them how it's being calculated rather than this. Okay, so basically that's about my presentation, and then we go for the conclusion, comment back from all our activities, what we have done, and then we summarize the loss, the risk assessment by the insurance, and the loss estimation. Okay, I strike down one of that because if you remember, the calculation also involve a business interruption, which is pretty much long, so I exclude that. Okay, and then we propose for further study for other thing. Okay, so basically that's it about my presentation. So if you have any question, we can talk about it on next Friday. Okay, thank you very much. Bye.